Welcome, guys. We are back. It is Mr. Campbell again here with day two for, I believe this is now week number 4. Moving on from yesterday's first day, looking at a little bit of new space galaxy stuff with our Big Bang Theory and what are called redshift and blue shift. Again, just as reminders, just so you guys know, workbook pages 323 through 326 are due at the end of this week, specifically on Sunday at 11 p.m. So make sure to be starting those. All the textbook pages have been posted on Edsby as well for you to use to answer the questions on those 4 workbook pages. We're also going to be having a notebook check and our next unit quiz starting this Friday. So in a couple of days, have your notebooks fully up to date with these YouTube video lessons because they will be used for you to assess and complete those assessments. Let's get to our Go Blue questions. Again, I will speed through. I will kind of go quickly through these different pieces of content. So make sure to pause the video as we go along. And this is going to be on page 4 preferably, but if you want to save some room on your notebook, you can have it on page 2 if there's still space left over. Number 1, what is the difference between red shift and blue shift? Number 2, what is Big Bang Theory? And number 3, what moons are present during neap and spring tides, right? So got to know the moons, got to know what the 2 concepts are from yesterday as well. Moving on to our answers here. Redshift, guys, are when objects are moving away from a source. So we get stretched waves. Keep in mind, most objects in space are going to be in redshift, hence why most stars appear to be yellow, orangish in color, because the universe is doing what? The universe is expanding, right? It is expanding. So red shift, moving away. And then we have blue shift. That's when objects are moving towards a source. So it's when these waves are being compressed. I would say one analogy I think I've always made in class includes, like, you know, if someone left you on red, right? Say that you sent a message and they just never responded back. You know, they're distancing themselves from you. It's like a star is distancing itself. And if you're feeling blue, people who are concerned or want to make sure you're okay, they approach you. They come to you, right? So again, red left on red, going away. Feeling blue, they go to you, right? That's what I always say. Maybe to help you remember it a little better. And then we can see here again, red shift again going away, blue shift going towards for our star colors there, right? Okay, number 2, what is the Big Bang Theory? It's the idea that the universe was created billions of years ago through an explosion or an expansion, you could say, of infinite energy at a single point. Okay, so going to be that expansion as far as we can explain it scientifically, right? So an expansion of energy at a single point infinitely, no space until that space expands full of all those elements and energy. And then for number 3, what kind of moons do we, spring tides? Your 2 moons would be full moons or a new moon. My bad. For spring tide, it's going to be, full moon or a new moon. That's going to be on either side of the other. Again, as long as we have a linear kind of setup between sun, moon, and earth. And the neap tide, it's going to be the first quarter moon or the last quarter moon. And those are in regards to there being a 90-degree angle set up for our sun, moon, and earth, right? Okay, that completes our Go Blue, guys, for today. Go ahead and add pages 4 through 5 into the universe day 2. Again, this would have been day 2 of our movie, our film we would have watched in class, but I kind of wanted to just sum it up for you guys in a presentation format because that's what's best and easiest for our YouTube video lessons. No need to make you guys pay for videos on YouTube right now because when I looked at that, it was not free. You had to pay for it, so I'm not going to make you guys do that. Practice question number 1. Blank tides have more extreme tides, while blank tides have more moderate tides. Is it going to be A, neap spring, B, spring neap, C, high low, or D, low high? What is the correct answer? Take a moment, think about it, pause this video. Answer is going to be B, spring and then neap. Again, spring tides because of the linear setup, higher high tides, lower low tides, and neap tides because of their perpendicular setup. Again, in that right angle, they're not going to be working together. So it's going to be more moderate, lower high tides, higher low tides, right? We call those neap tides, not spring tides. All right, let's go back to our Into the Universe notes, guys. This is going to be on page 3. If you need more room, again, I recommend you go to page 5. And before we get into our first topic is going to be titled the role of gravity. And what I'm going to do is I'm actually just going to show that little video up, a segment of it here in a little bit. But the idea is gravity played a massive role in forming our universe, our galaxies, and our solar systems. It determines where things go, how they form. Okay, so gravity is this attractive force that is affected by an object's two factors. We saw this in our last quiz, I believe, mass and distance. Okay, and the early universe was basically just a bunch of gas elements kind of floating around in particles that would clump together over time. Okay, and what clumped this stuff together, as you can see in these pictures here, what clumped it together was gravity, right? And gravity pulled these things together. And when enough elements fused, they ignited, they would collect and fuse and basically create what we now know today as our stars and galaxies, right? Let me go ahead and remove my screen here so you can see this better. But again, affected by an object's mass and distance clumping together from gravity pulling it together, right? Kind of like things settling together from gravity and water, right? If you are stirring it up, right? So let's go ahead and check out a quick glimpse of one of the videos I want you guys to watch on your own fully, kind of explaining the importance of gravity in our solar system.
We tend to think of space as just the stuff around us, but it's actually kind of a thing. It has a physical component to it, like a fabric, like a sheet.
In empty space, light travels in a straight line. But place something massive, like our sun, on the fabric of space, and its immense gravity warps space. As light travels past the sun, its straight path curves.
So light bends, not because the light bends, but the space in which the light is traveling curves itself.
Due to gravity, right?
This is why our probe's trajectory is curving. The black hole's gravity is warping the fabric of space. Everything that travels through this curved space must follow a curved path.
And we're to get into, in most galaxies, if not all galaxies, it's kind of like a spiral, and that spiral is formed by what we all know as a black hole, right? So we're going to explain those very soon, very fascinating topic. And those kind of like this, how the sun determines the gravity of our solar system. You'll see black holes are going to determine the gravity of galaxies, kind of in the same format. So let's go ahead and talk about other few things before we get to our last video here. All right. So our second topic I want you guys to look at is the birth of stars. How do we get stars? How do they come about? And how do they form? Well, we all know our sun, two main elements, hydrogen and helium. Okay, so first off, you got a ton of hydrogen floating around in space. Okay, gravity pulls it together, and kind of like striking a match, it fuses in a process we now know as nuclear fusion. From nuclear fusion, hydrogen is converted into what element? Another quiz question from last week. Into helium. Again, think of stars like balloons, right? Hydrogen gets converted to helium, which causes the star to emit light. So that hydrogen to helium relationship, that balance of those two elements, creates a healthy star, very bright, shining for billions of years. Now, this is going to form the first 26 elements on our periodic table, and the heaviest of those elements is going to go at the center of the star. But then that leads us to our next topic. Oh, let's do a quick question. So again, pause when I go too fast, guys, obviously, right? Keeping things concise. What type of tide will form from the Earth-Moon setup shown on the right? This is from our Go Blue earlier. It's a perpendicular setup, sun, Earth, Moon, and it's in a 90-degree angle, right? It's going to be A, spring tide, B, neap tide, C, high tide, or D, low tide. It's going to be, guys, again, B, neap tide. Neap tide is going to be in an L shape, a perpendicular format. Spring tide is going to be in a line working together. These are working against each other in the neap tide. That's why we get more moderate tides, not the extreme tides. Okay, so what happens after those stars are around for a long, long time and then they meet their end? Well, when the star stops producing helium, okay, it's going to start creating iron. And when it creates iron, it's going to burn out and basically die. Now, what happens when it produces enough iron? It's going to collapse and explode into what a lot of us are familiar with, a lot of us know as a supernova. This supernova, this explosion that we see down here in either format, it's going to create all the rest of the elements on our periodic table. A lot of those metals we're very familiar with. I think like gold, all those kind of metals. So it's going to be elements 27 through 92. So let's go ahead to finish up for the day. Let's go ahead and take a look at a little glimpse of what that would look like on the movie we were going to watch together in class.
The closer to the center, the heavier the elements, like neon,
Mentioned that earlier.
and last of all, iron. Now
iron?
things change. Iron doesn't produce energy when it fuses, so the fire begins to go out. More and more iron builds up in the star's core until almost all.
So the key element here to know, I underlined it on the slide earlier, iron. You're going to see iron a lot. Iron is what ultimately kills and destroys, what causes a star to die. And when it does die, it goes from a kind of a yellowish color to a more red color, which means it's kind of cooling down. Let's see what happens after that.
All the remaining fuel runs out. Now gravity takes over and squashes the star in on itself. As its core gets more and more compressed, its temperature soars until it's over 100 times hotter than the core of our own sun.
And then supernova.
Finally, the star collapses and explodes.
And those are where all those elements, those metals are going to form, right? Okay. So you guys can watch the rest of that or all of that on your own. Again, make sure to include on pages 5 or continued on page 3. We've got the birth and the death of stars, and we've also went over the role of gravity. So again, make sure to have those up to date. We've got our notebook quiz coming up. We've got our next unit quiz, not our notebook check coming up, our next unit quiz coming up, as well as our workbook pages that are going to be due Sunday at 11 p.m. Those notebook checks and those quizzes will have to be completed around that time as well. You guys have any questions? Again, feel free to message me on Edsby. And as always, we'll just keep staying on track, and I will give you guys your last video lesson of the week tomorrow. Otherwise, you guys have a great day. Mr. Campbell, signing out.